be matched with this graph. Okay.
Okay.
So can you draw this graph?
Yes, sir.
Hmm?
Yes, sir. Just a minute. So on this side,
No, you draw it as you draw. Then you will compare with this.
okay.
How do we draw? We take the numerator 0 and then we take the denominator 0. Should I tell you or you would try first? There is only one question or more than one question there.
There's more than one question on it, sir.
So I will tell you the first one and then you can try the next one.
Uh, there's only one question. I'm sorry, this one,
Okay,
and then there's only sub questions.
based on that one. So you first try, then we'll discuss.
Yep. Sir,
Yes.
sir, for the denominator I got the zeros as 2 and -1.
Okay.
And for the numerator, the zeros I got as um I think um -1 and 0.
Okay. So one thing you have to do here, that is, as we studied in the previous class, no, we have x square plus x in the numerator, and in the denominator, what do we have? X square minus x minus 2. I think this is what we have.
Yeah, yes, sir.
So you need to first factorize this. Of course, you have got by factorizing it, but you have to show here that it is x minus 2 into x plus 1 like this.
Yep, yes, sir.
Now, what you have to do is that x plus 1 is common to both of them. So you have to write that x upon x minus 2, and you have to write side that x is not equal to -1. Then only you can cancel them, because x plus 1 cannot be equal to 0 if you want to cancel them. That is, x cannot be equal to -1. So
Okay.
this is behaving as a whole. This is a whole.
Yep.
It is undefined for x is equal to -1. And then where the denominator is becoming 0, that is 2. So this is y, this is x, like this. And when you take the denominator as 0 at 2, then you take a vertical line here, like this, which is x is equal to 2. And this is the asymptote, because here you have x is not equal, x is equal to 2 is an asymptote. The numerator is becoming 0 at origin. There, this is a 0. So when you will plot the graph, there are 3 regions basically. How many regions are there? 3. This is the third region. This is the second region. This is the first region. One is an asymptote, another one is a 0. Now, when you take the third region, it will be positive because there is a plus sign outside. Then it will be negative. Then it will be positive. Now, if you want to draw this, what you will do, that this is since negative, so it is coming from minus infinity, because it is an asymptote also, and going in like this.
Yes, sir.
And since this is plus infinity, and it will go like this. One second, one more thing is there. There is a horizontal asymptote also. So before drawing this, we have to see the horizontal asymptote also. Horizontal asymptote will be, this is fine, x is here, positive, then 2, then negative, then 0, positive, this is fine. When we take x as infinity, this is f of x. So f of x is actually 1 by 1 minus 2 by x, so we'll divide by x. And when we put it as infinity, this will become 1. For x infinity, 1 by x is 0. Or minus infinity also. So y is equal to 1 is also an asymptote. So there is a line y is equal to 1 here, which is an asymptote. Then the graph would be something like this. And here it will be, this is the graph. Like this, and this one is like this. Is it okay?
So, but isn't this the same graph which they gave?
Now we have to see. Can you share?
Yep.
Mm, yeah, that is fine. Now show work. There you have to show that work, which I have written. So I'm sharing you. You can write it down.
So is it so is it correct or wrong?
It is correct, no?
Mm, yeah, it's correct. Correct, sir. Sorry.
One error is there actually that we have not also shown here. That is wrong on our side also. That as we mentioned above, 1 second. As we mentioned above, that at x is equal to -1, there is a hole.
Yeah.
So at -1, you don't get any output. So you have to show here while drawing the graph that this curve goes like this. And at -1, there is a hole. And then it goes like this. So I think they have not shown the hole there.
Yeah, there is no hole.
Yeah, then it is wrong. Then it is wrong because there has to be a hole. I forgot about it.
Right. Sir, so I should just write that there is no hole in his graph, right?
There is no hole at x is equal to -1.
Okay.
That is why it is wrong.
Done, sir.
Okay.
So then next is domain and range of f
Mhm.
of x.
Domain of uh, and range of fx, right? So as you can see from the graph, domain is the value of x. So what values you can't take? Sorry.
Bless you, sir.
So what values of x you can't take?
Uh, we can't take -1.
And
So x is greater than,
we can't take -1 for x and 2 also, because 2 is an asymptote. We
yeah,
can't take a whole also, we can't take an asymptote also. So this is the range, domain. A range are the values of y. So you can't take y as 1. So y can be real number, but it cannot be 1 because at 1 it is a horizontal asymptote. It is a horizontal asymptote, and this was a vertical asymptote.
yes, sir.
What is the next part?
State the intervals where f of x is positive and where f of x is negative.
That you can see f of x is positive from 0 to 2, and from -infinity to 0 except -1 it is positive, and 2 to infinity it is positive. So you can write it like this, that f of x is positive for x belonging to -infinity to -1, which is a whole union. This is union -1 to 0, union 2 to infinity. So -1 we have to eliminate in between. So we can't write -infinity to 0. Otherwise, -1 will get included. So we have to eliminate that. So we have to split this. And f of x is negative for x belonging to 0 to 2.
Okay. Uh, and the intervals where f of x is increasing and f of x is decreasing.
Okay, so f of x is decreasing left of the asymptote as well as right of the asymptote. It is throughout in decreasing.
So
This is
-2 or
throughout it is decreasing. It is decreasing here also, then from infinity it is again decreasing. So you will say that fx is increasing for x belong to real number, whatever its domain, except -1 and decreasing, not increasing. And it is not increasing anywhere. It is only decreasing.
Okay.
What is the next one?
Where f of x is increasing and x is decreasing.
F of x is increasing.
And where f of x is decreasing. The intervals where f of x is increasing and where f of x is decreasing.
That we have done now.
Oh yeah, then it's increasing. I don't think that is increasing, right, sir?
It is not increasing, it is only decreasing. Not increasing anymore.
Okay, then that's it, sir.
Should I share?
No, no, done, sir. So this, I think we did this assignment
Mm-hmm.
and now we're doing this. I think we didn't complete this. We were doing it.
Yeah, we did only vertical asymptotes.
Yeah,
Horizontal we have not done.
we were doing,
This we did.
yeah, we did this.
This also we did, no?
Yeah, this one, sir.
Horizontal asymptotes. A horizontal asymptote occurs when the degree in the numerator is same as the degree of the polynomial in the denominator. Okay. A horizontal asymptote can be found by taking the leading coefficient of the numerator divided by the leading coefficient of the denominator. Okay. Y is equal to a by b. Mm, x to the power n. Yeah, right. So fine. Next one. Yeah, discuss the following function. This is the behavioral graph of this asymptote. So I will ask you this function. What is this function?
This is 2x minus 3
Hmm.
by x plus 1.
So horizontal asymptote is obtained if the degree of numerator is equal to degree of denominator. So here, as you can see, the numerator has degree 1, that is the highest power of x, and denominator is also degree 1. So here as horizontal asymptote matter. Now, what is the equation of horizontal asymptote? It is y is equal to a by b. If y is equal to ax to the power n plus so on. Here it is bx to the power n, so on. So if you see in this example, it is y is equal to 2 by 1. A is 2, and here b is 2 by 1, which is 2. Which means if you draw a line, y is equal to 2, horizontal line, then this would be the horizontal asymptote. Now, if you draw the graph, you can see that the zeros of this graph are, for numerator, you will get 0 at x is equal to 3 by 2. And for denominator, you will get the asymptote as x is equal to -1. So this is vertical asymptote, x is equal to -1. And there is a 0, 3 by 2. So this is 3 by 2. So how many regions are there? Are you following?
Yes. Yes, sir.
So there are 3 regions. I'm writing here also. One region by this vertical asymptote, one region by this 0, 3 by 2. This x is equal to -1. So this is positive, this is negative, this is positive. So when you draw the graph, you may get something like this, that positive graph is coming from here because it is a horizontal asymptote, then negative. So it will go like this. And this is a vertical asymptote, so it will not cut this. And then positive, so it will be like this. Do you have this answer with you? Can we verify this one?
1 minute, sir. I'll check. No, it's not given, sir.
But it has to be this one only.
Hmm. 1 minute.
You can note it down
Sir,
from
so
here.
what do we first do? We take the
As we earlier doing, the same thing we have to do first. That is numerator 0, denominator 0. By
okay.
numerator 0, we get a 0 on the x-axis. By denominator 0, we get an asymptote. After this, we have an horizontal asymptote. That is new. For horizontal asymptote, we do a by b. That is the coefficient of x here and coefficient of x here. That is y is equal to 2, it will become. So we'll make a horizontal line, y is equal to 2. This will cut the y-axis here. This is the x-axis. Now, after knowing this, and we know that there are 3 regions, 1, 2, 3, because zeros and asymptotes are taken as the change of the sign. So 3 regions. From positive, we will go to negative, then again we will go to positive. Now, since there is a horizontal asymptote also, so we can't go like this, that it goes from here and goes till infinity. No, it will stop at y is equal to 2 because it is a horizontal asymptote. And similarly, here also, when we start from the asymptote from positive infinity, we won't go till downward. We'll stop at y is equal to 2 because it is a horizontal asymptote. Are you getting this?
Yes, sir.
So first write it down. I'm coming in 2 minutes. Okay.
Okay, sir. Yeah.
Should I scroll down?
1 minute, sir. I think. So can you scroll down? Done, sir.
Okay. So let us come to the next slide. Determine the horizontal asymptote, if any, of y is equal to this. So can you determine the horizontal asymptote?
Yeah, I'll try so.
You don't have to do any calculation here. You can just orally give the answer.
So, but shouldn't we split the middle term?
Why? What is the condition for horizontal asymptote?
Oh, x, we should get the x from numerator and denominator.
What is the degree of numerator?
2,
The highest power of x.
2,
What is the degree of denominator?
1.
So are they equal?
No.
So there is no horizontal asymptote.
Okay. So it should be equal for,
Yeah, that is what we studied. Na? Degree of numerator and degree of denominator will be equal. Then only horizontal asymptote is possible. And it will be a by b. That is the highest power of x in the numerator, which is having coefficient a, and highest of coefficient of x in the denominator, that is having coefficient b, a by b.
so the numerator should be the same. Sorry, the degree should be the same.
Yes. Then only horizontal asymptote is possible.
Okay. So there will be no horizontal asymptotes.
Yeah. Today you have 1 hour class or 2 hour class?
Oh, 1 hour, sir.
We can come to the next slide now. Oblique asymptote, okay?
Yes, sir.
Often called a slant asymptote, is a linear asymptote that is neither horizontal nor vertical. A rational function will have an oblique asymptote when the degree of the polynomial in the numerator of the function is 1 greater than the degree of polynomial in the denominator. Okay, that is the degree of numerator is equal to the degree of denominator plus 1. Can you understand this story? Just read
No,
this.
sir.
Just read this step by step.
Okay. 1 minute, sir. An oblique asymptote, often called a slant asymptote, is a linear asymptote that is neither horizontal nor vertical. A rational function will have an oblique asymptote when the degree of the polynomial in the numerator of the function is 1 greater than the degree of the polynomial in the denominator.
Yes. So
So would it be like a
when
linear
the
graph?
Yeah, when the oblique asymptote is possible. Can you understand that?
when it's a linear graph.
No, no. When the oblique asymptote of a function is possible,
So
when,
when the new degrees are only when the degree of the numerator is one greater than the denominator.
yeah, that is one
Like
mathematically written here. That is the degree of numerator is 1 plus the degree of denominator.
so like
So then,
cube and square.
yeah,
So it's like, for example, like cube divided by square.
square, correct. Or the previous one was there x square by x.
Yeah.
It was quadratic by linear. So in those cases, now let us come to the next slide. Determine the equation of the oblique asymptote of this. Okay, they have not said the method to find the oblique asymptote. Fine. Can we come to the next slide?
Yeah. Oh, that's it.
Okay. So let me tell you to find the oblique asymptote. I have also forgotten oblique asymptote. I will have to think a little bit.
Should I play the video? I think there's a video.
Yeah, you can play the video of this end question, which is this we have done. This also we have done.
Oh,
Yeah,
so is
yeah,
that
that was the one.
okay? Just a minute. Sorry.
Well, let me just search from the Google. I'll get it.
Yep. So they're telling us to use long division first.
Yes, yes, that is what we'll do. We'll divide. So this would be so it is simply the division. Okay.
Nice. Mm.
Okay, so it is simply the division of the polynomial. So if we have something like this, okay. So I'm sharing.
Yes, sir.
What was the question?
One, sir. X squared plus 2x plus 3
Yes.
by x minus 1.
Okay. So when you will x square plus 2x plus 3, you will divide it by x minus 1. So it will be x times x square minus x Then you will subtract like this, and this will be 3x plus 3, and plus 3, 3x minus 3, this will be minus plus 6. So the quotient here is actually giving you the oblique asymptote. That is y is equal to x plus 3. For 1 second. Y is equal to x plus 3 is the oblique asymptote. Now, if you want to draw this graph, you can draw it. This does not have a horizontal asymptote because the degree of numerator is not equal to the degree of denominator. This will have asymptote, vertical asymptote at 1, x is equal to 1, because the denominator will become 0 there. And the numerator x square plus 2x plus 3, if you want to make it 0, the numerator part, so its discriminant is 4 minus 12, which is minus 8 negative. So it is also not giving you real values. So in that case, this basically this have no zeros. So only two portions are there. This is positive, this is negative. And there is an oblique asymptote y is equal to x plus 3. So when you will draw y is equal to x plus 3, so you will get x0, y3, and y0, x minus 3. So this will be aligned like this. This one and this one. Now, this is an oblique asymptote, and x equivalent is a vertical asymptote. So when you will draw the graph of this one, what will happen? You don't have to do this much. They are just asking the oblique asymptote. So your answer is this, but I'm just explaining it to you. Now, if you draw the graph, what will happen? It will be something like this.
So, but we have remainder as 6, right?
Yeah, that does not have to do anything.